So first, again, we can't run a container. We can only run a pod. So, but in that pod, there's going to be a single container, and it will be almost as good as running a container. And the simplest thing we're going to do is run a ping in a container, and then we're going to scale that. So I'm going to use kubectl run. So we have to give the name that we want for the stuff that we want to run. So I'm going to call that ping pong -- image, and I'm going to use the alpine image, and then the command I want to run, ping go.gl. Okay, I just created a deployment. Okay, so I didn't even create a pod, I created a deployment. So we have to see what exactly this is about. What happened here? Well, I'm going to use kubectl get all to figure out what did we do. So I have this deploy / ping pong thing. So that's the deployment that I just created. And that deployment created a replica set, and that replica set created a pod. At first, this might seem complicated, but in a few minutes, you will understand why we have all those layers, and it will all make sense. But at least we have our pod here running somewhere. Perfect. Yes?
What does the get all command return?
What does the kubectl get all command do?
What does the get all command return?
So get all it doesn't get all the resources, but it gets a bunch of resources that are relevant. So I can't remember the exact name off the top of my head, but I think it will show us pods, replica sets, daemon sets, deployment services, and a few others. So it's just more convenient to do that rather than kubectl get pods, kubectl get replica set, kubectl get this and that. So
I'm just trying to figure out how we can distinguish what type of resources in this output that this command returns. So, okay, the prefix, let's say, to the deploy or rs or whatever.
yeah, sorry. In the name we have the type and then the resource name. So when it says deploy / ping pong, it means it's a deploy, which is shortened for deployment, and the name of that deployment is ping pong. RS is the shortcut for replica set. PO is for pod, etc., etc. Sorry.
This is now associated with the namespace.
And this is in the default namespace. So if I were to do like kubectl -n cube system get all, then I would get like stuff in the kube system namespace. If I don't put a namespace, I'm getting the default namespace or whatever is declared in the kube config file. Okay. So why do we have multiple levels? Like, why can't have just one pod and that's it? So by default, when I do a kubectl run like that, you think, well, you want to run that thing, but you're probably running like some kind of server or whatever, and you want it to be running at all times. You want it to keep running. So I'm going to put that in a replica set. A replica set is a construct that you can say, I want that many copies and I want them to be running at all times. And in that case, that many copies is one copy. Now, why do we have a deployment above the replica set? Well, that's because when you deploy something, at some point you will probably want to upgrade to a new version. Like when we write code, often we want to update something, like to update the code or change the parameters or whatever. And when we do that, we want to do a progressive rollout, like a rolling deploy. So what happens is that we have the deployment, and under the deployment, we could have multiple replica sets. Like this is old version. You want to put a new version? Fine, let's have a new replica set for new version, and we're going to kind of progressively go from old version to new version, and then we can destroy the old replica set, and each replica set has pods below. If this sounds confusing, don't worry. At the end, there will be an example showing that in action. Okay, so supposedly I've started a ping in a container, but I would like to check if that really works. So I'm going to do kubectl logs deploy / ping pong. And yep, I get the output of my ping command. You can also do deploy space ping pong. It's either way, which will amount to the same thing. Whoops. Logs. No, you can't.
Why it logs if it's output?
So it's the output of the containers, and I couldn't say tradition because tradition are things that have been around for a long time. But let's say the best practice with containers is that you write your output, your logs, you write it to standard output, and it will be collected by the container engine. So the idea is that instead of writing to log files and then you have something to collect these log files and ship them somewhere, you just write to standard output, standard error, and this will be collected by the container engine, and then the container engine can have an extra setup to ship that wherever you want. So yeah, I can interchangeably say the container logs or container output, but it is the same thing in that case. Okay. So I'm not sure if so the question is, if I have multiple containers in the pod or multiple pods or multiple things and I do logs, what happens? So by default, it will take the first one and show the logs for the first one. But so we have a couple of extra options. So I'm going first to show like log streaming, and then we will scale the app and we will answer the question. So if I want to see those logs live, there are a couple of flags that I particularly like that are --tail 1. So that means just show me the last line of log. Just don't throw me like all the logs at my face. And --follow, which is like the -f option in tail, and that will continue to like show me the logs in real time. Okay. So then we are going to scale that deployment. So I'm going to say, okay, I want more containers doing ping at the same time. So I'm going to do kubectl scale, deployment ping pong, and I put the container --replicas equal 8. And it tells me, okay. By the way, if I were to do a Docker PS at this point, I have a bunch of like kube-specific containers, but if I scroll up a bit, I should... No, I'm on the master, of course, so I don't see my ping containers. But if I go to node 2 and I do Docker PS, then I will see my Alpine containers doing ping good.gl. All right. Let's go back to node 1. So here, out of curiosity, what would happen if instead of scaling the deployment, I would scale the replica set? Well, I could, but then the deployment controller has some instructions saying, I want 8 copies. And suddenly it would see, oh, you want 8 copies, but the replica set just under you now has like 10 or 5 copies. That's wrong. I'm going to fix that. And it would scale back immediately. So there are a number of controllers for each resource that are basically the guardian of the state of the resource. And those controllers make sure that those resources and the resources depending on them are exactly the way you want them to be. Okay. Yeah.
How do we control where replica goes?
How do we control where the replica goes? So by default, I would say the whole point is that you don't have to, in the sense that Now, if we wanted to, there are many mechanisms to do that. For instance, we could put constraints on the deployment. There are mechanisms called taints and tolerations, which is a way to say, I don't want these specific things on these nodes, but then you can put exceptions to that, which at first seems like, well, that seems complex, but that's super useful for lots of system services. You can be like, okay, those nodes are going to host, for instance, my master services, and so I'm going to indicate nothing else should go there, or rather like nothing should go there except the pods and associated replica sets and deployments that have those specific exceptions. You can also, if you're doing maintenance, you can cordon or drain a node, which means like you can say, don't add anything on that node. or if you drain, it means get everybody out because we're going to shut down or do some maintenance on the node. You have a bunch of mechanisms like that to achieve that. So what happens if I destroy a pod? So I'm going to split the screen so that I can do kubectl get pods -w. -w is another super useful option. It means watch. So it's going to show me like continuously the output here, and that sucks. Okay, maybe I can do get pods. Well, let's do it that way. And now I'm going to try to destroy one of these pods. So I'm going to do kubectl delete pod ping pong dash blah 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 blah. And when I do that, we see, okay, this one is terminating, and almost immediately there is another one that shows up at container creating. So first, that one is going to be in terminating for like 10 seconds because it's not paying attention to signals, etc. So it would take a while before it's actually shut down. But the replication controller the replica set controller, because there is also something called replication controller. But the controller for the replica set is kind of watching exactly like what's going on with the pods. It's like, oh, you wanted 8 pods, and I see that now we only have 7. So I'm going to start a new one immediately to fix that. Okay. So what if we wanted to just start? Oh, and I'm sorry, I didn't show like the logs with the label. Yeah, it's just after, right? So what if I just wanted a one-shot job? Like I just want to. Yep, let's do the break in a couple of slides. Thanks. So there are other options like you with kubectl run, and kubectl run is kind of smart. And depending on these options, it would be like, I don't think you want to keep something running forever. So instead of creating a deployment, I'm going to create a job, or maybe just a stray pod. So you can also directly create pods with that. Each time we use kubectl run, what really happens is that kubectl is going to generate a YAML description, this is the thing that I want, and it's going to submit that to the API. And we can also do this manually. So if we want, we could like handcraft the YAML, or we could ask to kubectl, give me the YAML and I'm going to make some tweaks, and then we could submit that YAML with kubectl apply. All right, I'm showing the logs, and then we can do the break. So when I view logs, I can also do kubectl logs, and then I can put a label selector. So -L. And here I can put labels. So what kind of labels could I put? Well, to get an idea, I'm going to do kubectl describe pod, one of my ping pong pods. And in the output somewhere, I see, oh, we have labels here. We have run equal ping pong and pod template hash equal something. Run equal ping pong seems a good bet. So I'm going to do kubectl logs -l run equal ping pong, and that sends me the logs of all the containers in pods matching run equal ping pong. And I can add --tail1 to just get the last line of log for each of them, and that's pretty useful because you can see here like this one has a higher sequence number, so that was the first one, the original pinger, and the other ones have like 300 something, and this one is the one that was recreated recently. Yes?
And that output, it's like sequentially down from the first container to the last one, or it's somehow mixed?
What's the order here? It's random. I mean, I don't know if it's randomized each time, or if it's just, I mean, it's random in the sense that it's not going to show them in order by default. Yeah, if I run it multiple times, it will be in the same order, but that order is random. It's maybe we should check, like maybe it's just the IDs of the pod and you sort them alphabetically and that's it. Um, Now, sadness is that you can't do this. You can't do like a tail dash F on multiple things at a time. It's going to tell you, no, no, no. You can either stream the logs of one container in a pod, or you can do a label selection. So there are a bunch of projects that do that. There is Kale, like Kubernetes Tail. There is another one called Stern, I think. And so if you want to stream logs of multiple things at the same time, it's usually you have to install something like that.